Let's talk about solving equations with inverse trig functions. So solving equations with inverse trig functions. If you remember, inverse trig functions are things like sine inverse, cosine inverse, tangent inverse, arc sine, arc cosine, that sort of thing. Now, what we need to do is we need to remember algebra. So we need to remember algebra. That would be doing things like adding to both sides, subtracting from both sides, multiplying both sides, that sort of thing. Also factoring might come into this. We also have to remember exact values of trig functions. What is the sine, cosine, what are the sine, cosine, and tangent of 0, 30, 45, 60, 90, pi over 6, those things. So those exact values are going to come into play here as much as possible. Occasionally, we need to use a calculator, but the exact values of trig functions are actually more important. So those are some of the things we need to do. Essentially, in using algebra, we are going to try to solve for x, or whatever the variable is. Now, my examples that I'm going to use today have x in them, so that's fine. But we will need to get x by itself. Only one x in the entire problem, and it's got to be by itself. So let me give you a couple that are kind of generic, let's say, because they have both x and y. So here's a problem. Y is equal, so here's an example. Y is equal to minus the sine of x over 3. And in this one, x has got to be in the region from minus 3 pi over 2 to 3 pi over 2. Now you could graph that on your calculator and you'd have an idea what it looks like. But what this is supposed to be worked on here is we've got to find out what x is. So in order to solve for x, we need to multiply both sides by -1. So I've got negative y is equal to the sine of x over 3. And then to get rid of the sine, I've got to take arc sine. So I've got to go arc sine of negative y is equal to the sine inverse, or arc sine, those are the same thing, of the sine of x over 3. Now these two undo each other, so now x over 3 is by itself. So I've got x over 3. Then I multiply both sides by 3, and I will have x solved for. So I've got 3 times, now the arc sine of minus y is equal to x. This, not necessarily seemingly important, but notice that we could actually talk about what the arc sine of y is. If x is dealt with here between minus 3 pi over 2 and plus 3 pi over 2, then that's 3 times an angle is equal to x. So the angle that we've got is going to have to be between minus pi over 2 and plus pi over 2, because these are 3 times values. All right, so this is 3 times an angle, and it's telling us what's going on. So we could actually say something about the arc sine of y. Let's do that. This is the arc sine, actually the arc sine of minus y has got to be between now minus pi over 2 and pi over 2. So the arc sine of minus y is going to end up there. That minus pi over 2 to plus pi over 2, that is quadrant 4 up to quadrant 1. All right? So that's where the arc sine is going to be. That might be something that you find important. Let's look at another generic one. This one has y equals the tangent of 2x minus 1, and x has got to be between minus or plus a half minus pi over 4 and a half plus pi over 4. So if we need to solve for x, we need to undo tangent. So let's take arctan of y is equal to arctan of tan of 2x minus 1. So we've got the arctangent function of the tangent function of this. Well, these two undo each other, so this side is actually just 2x minus 1. So in order to solve for x, I need to add 1 to both sides. So I'm going to just get rid of this, add 1 to both sides, and then divide the whole thing by 2. So I've got 1 plus the arctan of y is equal to 2x, so then divide by 2, and we have 1/2 plus 1/2 arctan y equals x. Now if x is in this region, 1/2 to minus pi over 4, 1/2 minus pi over 4, 1/2 plus pi over 4, then what's going on if we happen to have it subtracted? What if we had subtracted 1/2? Now I know that seems a little bit like we're going backwards, but take a look at this. 1/2 arctan of y has got to be equal to x minus a half, right? So if I subtract a half from each of these, then that's going to tell me that 1/2 arctan of y has got to be in the region from minus pi over 4 to plus pi over 4. Well, arctangent of y is an angle, okay, so half of the angle has got to be between minus pi over 4 and plus pi over 4. So what about the angle arctangent? Well, if this is half of it, then we can actually double things and go minus pi over 2 to plus pi over 2. Now, arctangent has got to be between minus pi over 2 and plus pi over 2. If you look at the tangent function, it is undefined at pi over 2. Now, I'm not taking the tangent function, but if I took the tangent of this or the tangent of this, I'd have undefined. So I really need to make these open intervals because it's really not defined. Let's try some other things here. What if I have an exact, or an exact value? Here I don't have x and y, I just have x. So this one's got 4 and it's got arctan in it. 4 arctan x equals 3 pi. Let's solve for x. So let's divide both sides by 4. So now we have arctan x equals 3 pi over 4. To get x away from arctan, we need to take the tangent of both sides. So the tangent of the arctangent of x is equal to the tangent of 3 pi over 4. So these two undo each other. We get x. For here, what's the tangent of 3 pi over 4? Well, that is exactly -1. So that one works actually nice because we were able to solve for x, not in terms of y, but literally with a number. Let's try some other ones. I've got one here that says that it is arcsine of x is equal to arctan of 3/4. Now that thing is more difficult because it's got arcs on both sides, or inverse functions on both sides. So I am going to start out by looking at this. Arc always defines an angle, so I'm going to call it theta, and I'm going to say this: the arcsine of x is equal to theta, and I'm going to draw myself a triangle to fit my scenario. So I put it in quadrant 1. Here's theta. I know that the arctangent of theta, or of 3/4 is theta. So from the way that I define this, I know that the tangent of theta equals 3/4. Well, it's the ratio, not the exact values there, that matter. So tangent is opposite over adjacent. So I can make this one 3 and this one 4. Okay. Now, not only that, 3 squared plus 4 squared is 5 squared. So this is a 3, 4, 5 triangle. And then we come back and we say, well, all right, that's fine. Arc sine of x equals theta. So we had established that this was theta. So in order to solve this for x, we take the sine of both sides. So the sine of the arc sine of x is equal to the sine of theta. Now you might wonder what I'm doing with the triangle. Well, take a look at this. I've got x equals the sine of theta. We have theta. We have a triangle with theta. What is the sine of theta? It's the opposite right here over the hypotenuse. So that is equal to 3/5. So by establishing the value for one of these and doing some function work like taking the sine of both sides or the tangent of both sides, setting up a triangle, we're actually literally able to solve for x. Let's look at a couple more examples. This example has the inverse cotangent. So cotangent inverse of x is equal to the inverse tangent of 4/3. Now you might like this one. This one's kind of interesting. You probably know a lot about tangent and cotangent and how they're related. Be a little bit careful with this because arcs are a little bit backwards, so to speak. But let's take this one first. Inverse tangent stands for an angle. So let's draw triangle. Our tangent is 4/3, so that would be the opposite over the adjacent. So I've got 4 and 3. I know my sides aren't the right length. 4 squared plus 3 squared is 25, so that would make a 3, 4, 5 triangle, just like the last example. They're spaced differently. Opposite and adjacent are opposite of each other. Now, we've got this. We've got cotangent inverse of x equals theta. So cotangent inverse of x equals theta. Here's theta, by the way. So if I want to solve for x, I have to take the cotangent of both sides. So I took the cotangent of both sides. That process cancels or undoes itself, and so I get x equals the cotangent of theta. Well, look over here. Here's a triangle with theta. What's the cotangent? It is the adjacent over the opposite. Adjacent over opposite is 3/4. Now, the cool thing about this is cotangent inverse of x, tangent inverse of 4/3. So since cotangent and tangent are reciprocals, the answers to them are reciprocals, actually. So there it goes. So if you have 4/3 for the arc tangent, that's going to give you 3/4 for the arc cotangent. So that was the kind of interesting part there. Here's another example. This one has arc cosine of x plus 2 arc sine of square root of 3/2 is equal to pi/3. Solve for x as usual. Well, let's go through and do some of this. Now, first of all, I want to look at this. Arc sine of square root of 3/2. So if I've got arc sine square root of 3/2, and I say that's equal to some angle theta, then I know that the sine of theta is equal to the square root of 3/2. That is one that I have memorized, and so should you. The sine of theta is the square root of 3/2 when, notice this is in radians, when theta is pi over 3. So that's our theta value. Now I know that this is true a couple of places, but when we're working with inverses, we only get one answer. And if it's first quadrant, then that's the priority. So pi over 3. I'm going to just replace this in here. So I've got this. I've got arc cosine of x plus 2 times pi over 3. So 2 pi 3 equals pi over 3. Well, let's subtract this over. We get arc cosine of x is equal to minus pi over 3. So now, to solve for x, we've got to take the cosine of both sides. So take the cosine of the arc cosine of x. That should give us the cosine of the other side. We're performing the same function on both sides. That's appropriate in algebra. These functions undo each other. We've got the cosine of minus pi over 3. Well, the cosine of minus pi over 3 is in quadrant 4. The cosine's positive. The exact value for cosine pi over 3, which is what you need to remember here, is 1/2. And the cosine of minus pi over 3 is the same as the cosine of plus pi over 3 because of the evenness of cosine, and also that it's in quadrant 4 where it's positive. So our exact value is 1/2. So that one's kind of interesting as well. Okay, last example. I've got sine inverse of x plus tangent inverse of x is equal to 0. Okay, so two angles that add to 0. Well, you might be able to imagine what this is, especially if you know your values pretty well. But I'm going to start out doing the same thing I've been doing. So right here, I'm going to call that one theta. So here's the triangle where this works. Now, this is not one that has nice numbers in it, but that's okay. We'll get some numbers. Here's the angle theta, and we know that the tangent of theta is equal to x. That is the opposite over the adjacent. So this is x over 1. Like I said, this doesn't exactly have numbers. X represents a number. Well, what's the hypotenuse? X squared plus 1 squared is the hypotenuse squared, so it is 1 plus x squared in the square root. Now, we've got sine inverse of x plus theta equals 0. So we know this. We've got the sine inverse of x is equal to minus theta. I subtracted theta from both sides. So let's take the sine of both sides. Sine of the inverse sine of x is equal to the sine of minus theta. Sine inverse and sine undo each other, so we get x is equal to the sine of minus theta. Now, sine of theta and tangent of theta and cosecant of theta and cotangent of theta all work like this. If you take the sine of minus theta, it's equal to minus the sine of theta. That does not work for cosine and for secant. Cosine and secant are said to be even functions, and sine and cosecant and the rest of those are odds. So when you've got sine, tangent, cotangent, or cosecant, and you've got a minus here, it actually is the same thing as putting it out in front. So I now have this. I've got x is equal to minus the sine of theta. Now, if you are unsure about that, make a triangle with minus sine of theta. What does that do? With minus theta. This is minus theta, so this one goes down x units. This is still 1, and this is still square root of 1 plus x squared. So what's the sine of that? It is opposite over hypotenuse. So sine of theta. is minus x. And so we've got to deal with that a little bit, okay? We've got to solve and keep going here. So what is the sine of theta? Well, I've got it sitting here as minus x, but the sine of theta is equal to this over this. So it's also equal to x over the square root of 1 plus x squared. Now you might say, hey, that can't happen. Well, yes, it actually can. So let's take this and finish our problem. So we've got minus x is equal to x over the square root of 1 plus x squared. If I square both sides, I've got x squared is equal to x squared over 1 plus x squared. Cross multiply. Let me get some more space here. So then I'd have 1 plus x squared times x squared equals x squared. Let's divide through by x squared. All right, so this leaves a 1. And so now we've got 1 plus x squared equals 1. So subtract 1 from both sides. If we subtract 1 from both sides, we get x squared equals 0. And so x equals plus or minus 0, x equals 0. So long story short, or short story long, sine inverse of 0. Where's the sine 0? It's 0. Tangent inverse of 0. Where's the tangent 0? At 0. So 0 plus 0 equals 0. Now that doesn't sound too exciting, but it's got some kind of fun pieces.